Welcome guys, you are welcome back to Physics Solution, and this is the next question we'll be solving today. So the question, remember in our last lesson we solved a question pertaining to the conversion of galvanometer to an ammeter. So here today we'll be solving a question that regards galvanometer to a voltmeter. And here's the question. It says that the figure above shows a resistance R which is used to convert a 50 ohms galvanometer of full-scale deflection of 50 milliampere into a voltmeter with full-scale deflection of 60 volts. The value of R is, and remember in our last class I made mention that the resistance that is used to convert a galvanometer to an ammeter should be a shunt, which is a low resistance, which will be connected to the galvanometer in parallel. But in the process of converting a galvanometer to a voltmeter, we will be using a multiplier, which is a resistor of high resistance, and it will be connected in series to the galvanometer. So here, as you can see, the resistance is connected in series. So this is how we do it. Since from our knowledge of current electricity, we know that when we connect a resistor in series, if you connect any appliances in series, the same current will flow through them. So if that is the case, we will realize that the current flowing through the galvanometer is 50 milliampere. That is the same current that will also flow to the resistor. So using that knowledge, we can use that to get the potential difference across the galvanometer and the potential difference across the resistor. So the potential difference across the galvanometer will be equals to the current multiplied by the resistance of the galvanometer, and the maximum current that can flow to the galvanometer is 15 milliampere. If you convert 15 milliampere to ampere by dividing by 1000, you get 0.015 ampere. So if you multiply that with your resistance of the galvanometer, which is 50 ohms, you will have a potential difference of 0.75 volts flowing 0.05 volts across the galvanometer. Now if that is the case, the next thing we will get solving will be the potential difference across the resistance. And since we know that same current will flow through both the galvanometer and the resistance, so the current flowing through the resistance will also be 0.015, and we do not know the resistance of the resistor, so we represent it by R. So the potential difference flowing through the resistance is 0.015 R. So moving on, since we know that the total potential difference across both the resistance and the galvanometer will be equal to 60 volts. That is the total potential difference that the voltmeter can measure. That is the full scale deflection of the voltmeter. So since that is the maximum potential difference, so we know that the maximum potential difference will be equal to the addition of the potential difference across the galvanometer and the resistance. And in doing that, we have our Vt to be equal to Vr plus Vg. The Vr is the potential difference across the resistance, while the Vg is the potential difference across the galvanometer. So we know our total potential difference to be 60, and our Vr to be 0.015 R, our Vg to be 0.75 volts. So when you solve further, you divide both sides by 0.015, and you will arrive at your answer, which will be a resistance of 3950 ohms. This is the resistance that is required to convert the galvanometer into a voltmeter that can measure up to a potential difference of 60 volts.
Thank you so much for staying with me to this very end of the class. I believe you've gained one or few things from this lesson today. Endeavor to watch the video over again for more clarification. Feel free to drop your questions in the comment section below or send to the email below. I so much appreciate your attention. Endeavor to subscribe to my channel. See you again.